Hi, this is Ms. Park, and this lesson is called Solving a Linear System by Elimination. So just to remind you that a linear system means that you have two equations happening at the same time. If you were using a graph, that would be like two lines on the graph at the same time. And the point is to find the point of intersection. So I'm going to do three examples. So here's the first one. And you should have already seen the method of substitution at this point. In the method of substitution, you would take one of the variables in one of the equations and rearrange that equation to isolate it, and then take its isolated expression and substitute it into the second one. Okay, so if you're not comfortable with substitution, please practice solving by substitution. The solving by elimination can be a little bit easier in certain circumstances. So we're going to do the three examples and you'll see. So what we do with elimination is this. We look at our two equations and we see they have two variables. We don't know how to solve one equation when it has two variables. So we do need two equations if we have two variables. So something we can do with equations is if the first equation is true always and the second equation is true always, that's what's happening here, then, and they're true at the same time, then if I add the two equations, the resulting equation will also be true. What I'm going to do is I'm going to put a plus on the left-hand side and draw a line underneath. So this is just like addition when we first learned to add, kind of up and down. And I'm going to add these two equations together. So I'm going to get x plus 3x and I'm going to get 4x. Next, I'm going to get y plus negative y. Now, y plus negative y will give me 0. And that's good because I want to eliminate one of the variables. So by getting a 0y, I've actually eliminated a y from the resulting equation. So I'm not even going to write it. I'm just going to leave a space. And then I have a 2 plus 2, which is going to be 4. Now my resulting equation, it has only one variable, and we know how to solve equations with one variable, so we can go ahead and do that. Divide both sides by 4, and I get x equals 1. Okay, so method of elimination is adding or subtracting the equations so that you eliminate a variable. Okay, now I've solved it for the x. Now point of intersection has an x and a y, so the rest of it is just like substitution. You take your x equals 1 and you substitute it into either of the equations. So I'll substitute it into equation 1. And so I'm going to go 1 plus y equals 2. And then y equals 2 minus 1, y equals 1. So my point of intersection is 1, 1. Okay, it's xy, so it's 1, 1. Let's do another one. We'll do this. Question 2, 5x plus 2y equals negative 11. 3x plus 2y equals negative 9. Okay. Actually, this is 1a. We'll call this 1b. So it won't be one of our three. Yeah, I would like to do two more after this. Okay, so in this case, if we add the two equations, I will get 8x and I will get 4y, and I won't have anything going to 0. So I won't eliminate either of the variables. So that means that adding the equations here will not be helpful, won't eliminate anything. So we can try subtracting the equations. So I'm going to put a minus on the left and then draw the line underneath, and we're going to subtract just like regular subtracting up and down. So 5x minus 3x is 2x. Now I have 2y minus 2y, which is going to give me 0y, so y's are gone. And now I have negative 11 minus negative 9. Be very careful, negative 11 minus negative 9. That's like negative 11 plus 9, which is negative 2. And here's my equation that's left with just one variable. I know how to solve this. And I get x equals negative 1. The rest is exactly the same as before. Sub x equals negative 1 into, you pick whichever equation you want. How about we do equation 2 just for fun? So 3 times negative 1 plus 2y equals negative 9. Negative 3 plus 2y is negative 9. 2y is negative 9. We're going to add 3 to both sides. So I'm going to get plus 3. It's going to disappear from the left, but it's going to be plus 3 on the right. 2y equals negative 6. 2y divided by 2 is negative 6 divided by 2, so y is negative 3. So the point of intersection is xy, negative 1, negative 3. Okay, so it's adding or subtracting the equation. You might notice that adding and subtracting the equation will only get rid of a variable if the coefficient is the same. So here you have a 1 and a negative 1. Here you have a 2 and a 2, and you can subtract them. Okay, so my next example is going to be what if the coefficients are not the same? So I'm going to do example 3 and 4. So in example 3, I'm going to have 3x plus 5y equals 12. Example 3. 3x plus 5y equals 12. That's equation 1. And then we have 2x minus y equals negative 5. That's equation 2. Okay, so now we notice that if I add these two, I'm going to have 3x plus 2x. That's not going to make a 0x. 5y and negative y, that's not going to make a 0y. Even if I subtract them, I'll have 3x minus 2x, that doesn't make 0x, and 5y minus negative y doesn't make a 0y. I'm going to have to do something else. I'm going to have to create equivalent equations. So if I take my equation 2 and I multiply it by 5, that means if I multiply every term in equation 2 by 5, then I could make a 5y. So watch, if I take every term in equation 2 and multiply it by 5, I get a 5y, and equation 1 won't change. It's fine. But look what I've done. I now have a new equation 1 and a new equation 2 where the 5y's line up. Now, this equation 2, they're equivalent because we know with equations, if we do something to one side and we do it to the other side, then the equation remains true. So what I've done is I've multiplied both sides by 5, which really means I've multiplied every term on both sides by 5. So equation 2, I've just written it in a new way, but it's exactly the same equation. And now I have a plus 5 and a minus 5. To make a 0, I will need to add those two. Okay, so I'm going to add the two equations. So I'm going to put a plus, draw the line, and 3x plus 10x is 13x. Positive 5y and negative 5y, when you add them, you get 0y. So we can eliminate the y's. 12 minus 25 is negative 13. So 13x divided by 13 is negative 13 divided by 13, and x equals negative 1. Okay, and then the rest is the same as before. Sub x equals negative 1 into, pick one of the two equations. Let's go equation 1. X is negative 1. 3 times negative 1 plus 5y equals 12. Okay, so this is negative 3 plus 5y equals 12. 5y equals 12 plus 3. 5y equals 15. And 5y divided by 5 equals 15 divided by 5, so y equals 3. So therefore the point of intersection, which is xy, is negative 1, 3. Okay, and for my final example, I'm going to have the two equations have no coefficients in common and something else. So let's do 2x plus 3y equals negative 18. 2x plus 3y equals negative 18. That's equation 1. 3x minus 5y equals 11. That's equation 2. Notice that even if I multiply one of the equations by something, there won't be any way to add and subtract. There won't be any way to eliminate. There's no number that I can multiply, let's say, a 3 by to get a 2. There's no number I can multiply a 3 by to get a 5. So we won't get them to line up. So what we can do is we can multiply both equations. So let's say you can pick a variable that you want to eliminate. So let's say you want to eliminate the x's. One of them's a 2x, one of them's a 3x. If I make them both 6x, then they will line up. To make them both 6x, I'm going to need to multiply the first equation by 3. And I'm going to get 6x plus 9y equals negative 18 times 3 is negative 54. The second equation, in order to make a 6x, I'm going to have to multiply by 2. So I have 6x minus 10y equals 22. And now I can do regular elimination. I see the 6x and the 6x line up. Should I add or subtract? Well, I want to get rid of the x's and make them 0, so I will subtract. So now we have 6x minus 6x is 0x. We don't even write it. 9y minus negative 10y is the same as 9y plus 10y. That's 19y. Negative 54 minus 22 is negative 76. Divide both sides by 19, and you get y equals negative 4. The rest is the same. Sub y equals negative 4 into either of the equations. Let's go equation 2. Then 3x minus 5 times negative 4 equals 11. 3x plus 20 equals 11. 3x equals 11 minus 20. So 3x equals negative 9. We'll just go over here. 3x divided by 3 is negative 9 divided by 3, so x is negative 3. So the point of intersection, which is xy, is negative 3, negative 4. Okay, and there you have it, the method of elimination. Please practice, and thanks for watching.